Morning.
Should we wait 2 minutes more? What do you think, Raphael? Is there more people coming?
How many people do we have now? We have 9, no, attendees 27. Okay.
So maybe
maybe we can wait 1 more minute and see if some people are still arriving. So let's wait 1 minute and then you can start.
Okay. Is my screen sharing because I have some problem with the font sizing?
No, we don't see your screen. No.
Okay, I need to see what happens here. Open share tray, screen share, okay. So now it should work.
Yeah.
Yeah, we can see your screen, and maybe we can start. We reach more than 30 participants, and it's pretty stable.
Okay.
Please, Stefan, go ahead.
I'd like to welcome everyone to this 7th Diagnostic I&C workshop. This October is wrong. I will correct it. It's May 11 and 12, today and tomorrow in the morning, because it's much easier for Asia to join. And we have the agenda, which you have seen in the invitation. And today we have quite interesting topics because many I&C developers are now going to the manufacturing phase. And there's always question on how to develop I&C, so EPIC support for all the devices. And we will get a presentation from Sergio on that. It's a lecture style with discussion. Then today we will get a lab, I&C lab update from the Corpia lab from ITER. Then we make a short break, which is also a buffer in case we are running a little late. And then in the second part, after the coffee, we will have a presentation on the image reference systems. Since we have so many cameras in diagnostics, it's quite useful to have some reference system on which one can use as a basis for imaging diagnostics development. And then a discussion on acceptance criteria, which we have developed to be clear of what we want to see during acceptance testing. Then tomorrow we will have prototype demonstrations. It will be a combination of slides and maybe live or video demonstrations, we will see. And we will discuss then the implementation workflow, because many developers are now in FDR stage and go soon to MRR and manufacturing. Some prerequisites for efficiently participating in the workshop is that one has some familiarity with the acceptance criteria, for which I put the IDM link here, and some familiarity with the usage of STD for this STD presentation. And the workshop IDM folder, that's easy to find when you go under PBS Kodak, and then meetings 2022, you will also find this link. Maybe what's interesting to see is the current stage of all I&C systems of diagnostics for the different countries. And what we see here is the front line is all the systems, the number of systems that have passed CDR. In the last line, you see PDR. And in the middle, you see FDR. It's only made in this way for better visualization, because FDR is not so mature yet, so these numbers are a little bit smaller. But you see a substantial part of the systems are now at
Stefan,
PDR stage. And
Stefan, sorry to interrupt. Could you click on hide on the bottom of your?
yes.
Yeah.
Okay.
Sorry. Thank you.
Thank you. I didn't know. Yeah. Okay. Yes. Sorry for that. And there's a few systems for which we don't have a maturity level yet assessed, but they are still at these stages with equivalent maturity. And after having reached FDR, the next steps will be coming, and that we will manage in a future workshop. That's the manufacturing readiness review, where we need a system manufacturing specification and a manufacturing inspection plan. And then the acceptance testing, for which we will lay the basis today with acceptance criteria, and later the integration with central CODAC, which also is a very interesting topic, which we will cover in one of the next workshops. And I think that's the end of my introduction. And we can start with questions or the next presentation. So are there any questions? Seems not.
Maybe I can ask a question. I only received the invitation for the first day of the codec workshop and not for tomorrow. Do you know why?
We have sent both.
I will forward it to you.
Okay, thank you very much.
Okay, that's clarified.
Okay, any more question? Otherwise, Stefan, maybe we can jump to the next presentation, or the first presentation from Sergio. What do you think?
Yeah.
It's okay? Yeah.
Yes.
Okay,
Okay.
so please, Sergio will present us the device support development. So this is an overview. You have, I see in the agenda that you have 40 minutes, so it's pretty long presentation.
Yeah.
But okay.
So
Let's go, Sergio, please.
can you see my screen?
We can see if you can go full screen. This will be best. Yeah, we can. It's okay.
Okay.
Thank you.
Okay, so thank you, Rafael. I'm Sergio Skermi. I'm a member of the Central Control Integration team. And in this talk, I want to give you an overview of the things that you should be considering when integrating a new device for the instrumentation and control of a plant. And also some hints on the tools that are available for help the developers while doing this task. As Stefan said, these slides are uploaded into the workshop folder, and I commented them so they can be used also for later reference if required. It has some technical comment. So this is the overview, the index of the talk. I will first have some notions on what is the context for this I&C and in which we will be integrating the devices, and then we will be covering what are the requirements for when that we need to consider when we are integrating a device into a plant system and into ITER. And especially, as we will see, into epics, because it's one of the most important things to consider when developing a device integration. Then we will cover NDS. That is one of these tools that are available for the developers to ease this task and to help in the development. And we will make an example on a very quick and simple example on how coding with NDS looks like, just to end with some conclusions. So regarding the context, we must consider that we are in a very big experiment, very complex one, when we have a huge number of different plants, very heterogeneous, with different controllers, with different for different purposes, and each one with different form factors, different devices, different requirements on throughput, speed, bandwidth, number of channels, and so on. So this is very complex to manage, and moreover, if we consider that each controller will be working mostly differently, and also that these systems are developing worldwide. So we have a huge number of different developers, including the DAs and the contractors for each system. So, and all of these must be working together. So all must be operated together and integrated into one system. So we have a very complex task when we are talking about integrating all of these plant systems. So our context here will also be this part below the red line. So we are in the plant I&C, and the rest where we are interfacing is the central control system, the Kodak system, in which we have the different applications and services. So this is defined by ITER, and this is in the scope of ITER. And if we get a simplified version of this, finally, we have our systems that are the slow or fast controllers. I don't know why the pointer got stuck. So we have the slow and fast controllers connected finally to some front-end signals and some networks. And that network layers that will give us the interface to the control system applications and services, and also, for example, including the archiving services and the operator terminals. Okay. So just to give a small recap of what are these all these networks and so on. So we first of all we have the Kodak core system, that is the software infrastructure that is used in all ITER computers except for the PLC ones. Okay. So this includes the operating system and all the software tools that must be used in those computers. Then we have the PON, so the network for operating the plant systems, and as you might know, this is based on EPICs and the EPICs protocols that we will see later. Then we have some high-performance network, one for archiving, the DAN, and one for real-time applications. So, for example, everything that is passing data to the plasma control system, or any interface with between the plasma control system and the rest of the plants. And finally, we have the TCN, that is the timing synchronization network, that is based on the precise time protocol. So now that we know where we are in terms of the ITER context for our development of the instrumentation and control, let's go to the device integration. And first of all, as always, is to consider what are the requirements that we have for this. Okay. Here it's important to consider that ITER has this big document that is accompanied with also a big number of satellite documents. That is the plant control design handbook that defines the requirement for every say plant system in ITER that must comply. Okay, this is what is presented here is not a complete list, it's not an extensive list, but it's one I wanted to represent here. The topics that will be mostly considered in this talk. So by one side we have the software requirements, in which we must integrate our system into Linux and EPICs, and ultimately also in SDT, but there are some other talks regarding this. Then also we need extensive documentation for the system, for the operators, and and for ensuring that the plant meets the requirements. So for example, test plan and test report, documentation for the software, both for the user and future developers, because we need to consider that this needs to be maintained for quite a long time. So that is also one important issue to consider. Then regarding the hardware, we need to integrate our plan system in the cubicle and have a procurement plan with obsolescence management, prove the compatibility of our system with the magnetic fields and radiation that we will have at the machine, depending on where are the location of our system, and also have an analysis on the reliability and availability of our system. Regarding functional, again, as I present you the architecture before, we need to have interfaces with the timing network and the data networks. Okay. Also, ITER has defined a catalog for slow controllers, for fast controllers, in which we have a set of devices that we consider that have been proven this compliance, and then considering this hardware catalog, we can define and the compliance with the design with the handbook. We can consider integration of 3 different kind of devices. So devices that are already in the ITER catalog, so the compliance is already demonstrated. Some commercial or custom devices that are not in the ITER hardware catalog, but we will demonstrate the compliance with these requirements. On the last case is that we have a commercial custom device. We won't demonstrate the compliance, and then we have a policy to deviate from these requirements. Okay. So for the second case, let's consider what is the workflow for that. So we have our plant, we have our instrumentation and control system, we have our requirements. And then we look in the PCDH and in the catalogs, and then we first of all we might have some aid with the IO experts to see if there is some new solutions required, or we have enough what is already in the catalog. So if there is nothing to do, if everything is in the catalog, then we just take this hardware that is already supported by ITER, and we start with all development. If not, then the first thing will be to evaluate what is the commercial commercial devices and have an evaluation on the market. If we find something in the market, or we decide that we are going to develop our own device, then we make a proposal. Okay, but we must ensure that this proposal will fit all these requirements, because in this case we are aiming to demonstrate compliance with the PCDH and the ITER I&C requirements. So for demonstrating this compliance, we will start by prototyping, and that means integrating the device into Linux and Epix and provide some documentation on this prototyping. So we make our development, and we elaborate a test plan and test report that we use it by IO and for future users of this potential hardware to be included in the catalog, to demonstrate that effectively it is working and integrated into the ITER environment. Okay, and then also to fully comply with the PCDH, we must demonstrate industrialization. And this is not an easy task, because we must consider that ITER will have a long lifetime, and we must provide the feasibility of the use of this hardware device during the whole ITER lifetime. So apart from the integration with Linux and Ethics and Epics and all the documentation related to the software and to the hardware, we need some important points that are not always considered is that we need to provide guide for the software maintenance, because eventually we may need to change, make some change in the plan. The requirements might change or might be upgraded for the different stages in the lifespan of ITER, and also for the hardware. So we need to set up procurement for the hardware and ensure that the hardware will be available during the ITER lifespan, and the obsolescence management of that. So at the end is to provide management of the life cycle of this hardware device for ITER. So then what we will get is that this new piece of hardware will be included into the fast controller catalog. So considering this and the three different kind of devices that we were talking regarding these requirements, we can see that if we find our solutions in the hardware catalog, we have less work to do. And of course, we have all the compliance that will be managed by ITER regarding this requirement, and it will imply lowest cost and risk. Then if we need to demonstrate this compliance with a new device, then there's additional work to be done. The most important is to provide this life cycle management for the industrialization. So it might imply significant cost. Well, I did not enter into the latest part because obviously it's the one that deviates more from what we want to do, and it's the highest cost and risk, not only for the plant system development, but also for, I think that for the ITER project. So here I suppose that the main message is that the safest and the cheapest option for everyone developing a plant system I&C is to stick with the ITER hardware catalog as far as possible. But of course, not all the possibilities have been considered, and it might be required to provide the compliance with this. Okay, so now that we set that clear, let's go to the integration of the device, what that means, especially the integration in Epics. So we have our piece of hardware that will be connected to a computer, a slow controller or fast controller. Normally, we have a low-level kernel module and then a user space library. And with that, we must develop our I&C application. And this I&C application must have interface with Epics for the control, and then with possibly with the other networks. Okay, but here we will focus mostly on Epics, because as we see, if we do things in a certain way, the interface with the other networks will be already given to us. So as also again a small recap, just in case that you are not familiar with Epics, and this is an important topic in the talk. Sorry, I don't know what happened. Okay. So Epics is a set of software tools and applications for having a network distributed control systems. So in Epics, the computers, the controllers that will be handling the hardware are the Epic servers and are called IOCs, input-output controllers. And these input-output controllers will communicate, will manage the hardware by communication of some variables that is called the process variables through a specific network protocols. So that in Epics are the channel access or the PB access. So what we have is that we have a piece of hardware connected to a computer that will be running the IOC. So in our case, this IOC will be running in the fast controller or the slow controller. So this controller will have a set of PBs that will serve for the operators that will be in another part of the network, running an interface and they will make changes in these process variables to handle the software, the hardware, and read these process variables to get the values from this hardware. Okay. Here, the objectives are using EPICS and all the tools that will be presented here. I think that for us integrating a device and in general, we must focus on not reinventing the wheel. So focus the development on particularities on our system are reused as much as possible, as long as it fit to us. And also to keep in mind that when we cannot find something that we can use because our requirements are very different or are not considering the other one in the existing developments, we must try to, as far as possible, to do something that can be reused by others. So keep the things that general reusable for others, and then have the specific as contained as possible. Okay, and with that, the benefit that we will have for us and for the project is to have better software quality, because we will have more users raising bugs and testing our software, and that also have an impact on the maintainability of the system. Okay. And if we create this ecosystem, yes, we create this environment in which we can reuse as much as possible, and all development only for the specific, we keep the developments to the minimum. So with all the impacts in the cost that has. Okay, so I think finally this approach is better for all. Regarding the integration in EPICS, we can talk about mostly 3 approaches. So the pure EPICS approach, the IC driver and the NDS. With the pure EPICS, as we talked before, we have the IOCs and the PBs. So the pure EPICS support will be just define a custom set of PBs that will represent our system. So the set of variables that will manage our system for the inputs and for the outputs. And then we implement a specific device support for each PB type, or for each PB record type. So we will have a specific, a small part of software related to each one of these PBs. Okay, and this small piece of software in all these PBs will make calls to our device library. Okay, the problems with this approach is that asynchronous calls are managed quite with quite some difficulties, and we have custom set of PBs, so we can say that we have no standardized operation for that. So every device will be managed in their own way. Doesn't matter if we are talking about data acquisition device with 4 analog channels. One device interface will look nothing like the other one. Okay, because we have no means to standardize that. And then, of course, this was the beginning of the development with EPICS. Then the ASIN driver framework came out. So with ASIN driver, we still have a custom set of PBs, but instead of having small pieces of software scattered through the whole set of PBs, we had one central core that has a generic support for the PBs, and we have the API of ASIN driver that let us to associate that PBs to one big, let's say, a bigger library in which we will represent our device driver. Okay, so we implement an ASIN driver with as a unique thing, as a unique unit, and the interface with the PBs is already generic thanks to the functionality provided by async driver. It also provides nice support for the asynchronous call, so that's another advantage of this approach. But we still lack of a standard operation because we have a custom set of PBs. So finally, we got to NDS, and there are other approaches in the EPICS world for this, but the one chosen by ITER is NDS. So here the main focus on this is to have this standardization, to have that two devices that even if the hardware is different, the functions are similar. In principle, they could be operated in the same way. They may have a very similar interface, if not exactly the same, even if the operation behind that interface is different, because the device finally is different and the kernel is different and the library is different. Okay. So here NDS use async driver for this generic PB support. So the same approach that we talked before, reusing what is already there, not reinventing the wheel. We have this the support for the asynchronous call given by async driver, and we standardize this set of PBs. We have a standardization also on the operation, while we have means to provide customization of this interface. So if the standard interface does not suit us, because we have some of the functions that no one considered before, we can still reuse what is there and just add some functions that are not considered before. Okay, but I will explain this soon enough with the demonstration of NDS. So I already said that this is a framework included in the ITER CODA core system to standardize the structure to implement this device. And this standardization and this means of operating at the different devices with the same interface is given by providing a predefined set of nodes that represent the most common functionality that we will have in data acquisition and processing device. That is mostly what we have in the diagnostic and the fast controller and the slot controllers. So we will represent a device as a tree, a hierarchy of this node with specific functions. And but of course, the functions for these nodes, the final implementations of, for example, for the health monitoring, we will have a means to get the temperature from the device. But the temperature of the device finally will be a different call for each driver, because it's not the same to get the temperature from a PXI device than from a Micro TCA or a PCI Express device. So each one will have their own library. So what we do is that we have this interface implementation pattern. So we define a hierarchy of nodes made with a standard NDS node, and then we will provide implementation for these nodes that will be the links to our own device library. Okay, I will explain this a little later. And the good thing is that I said we can extend these nodes. So for example, if for the health monitoring we have the temperature, but no one is not considering the standard NDS to have the signal quality of the device, for example, and we want to add it to the health monitoring, we can add it without modifying what is already there. So we reuse and we just add functionality, okay? And we can even create new nodes if we really consider it necessary. That normally won't be the case, okay? So, and a small, just to give you an overview of what is this architecture of classes that we would like in NDS driver, in an NDS driver. So by one side, we have a standard NDS devices that are like hollow, are just interfaces. They will just define what is the functionality expected from a state machine or from a firmware node. So each one of these nodes will have their own process variable, their own PBs their own means to access this functionality. So for the firmware node to get the firmware version of to change the firmware whatsoever, but they are not tied to a specific device. Okay. And then we can create our own device that will create this custom structure of nodes, because for each device, the nodes composing that device will be different. But it will be made of standard pieces. And then we provide the implementations for these state machines, for the firmware node that finally will be doing calls to our level driver. And this is just an example of, okay, we have a hardware monitoring node that has a PV for temperature, but has not considered signal quality. So then we can add that functionality to the node. And thanks to the NDS framework, we will have that interfaces to the control system. Okay. And the use of NDS has also the advantages that with NDS you will have also already implemented interfaces with DAN and SDN, and you have quite a number of devices that count already with support in NDS, so they can be used as reference, or just reuse it as they are for the development or your own system. Okay, and this framework is supported by IO, so any problem that you might find on it, IO will try to find a problem for that instead of you trying to develop your own thing. The dependencies for this is, of course, to be using a standard Codac core system. We have 2 libraries to use that are on ITER Git, and we have extensive set of documentation and examples to take as a reference. Okay. Regarding the NDS devices that are already supported by ITER, we have the NDS iRio that is support for FlexRio, CompactRio, and our series National Instrument FPGA devices. And we have an example available with analog data acquisition. Also support for the X series data acquisition boards of National Instrument, and timing board that provides synchronization with the PTP protocol, so with the TCN. Regarding micro TCA, we have also a timing card from in the micro TCA form factor, and a driver developed with for a FMC carrier board, with an example for one of the diagnostic system in ITER. That is a FMC carrier board with an analog acquisition input-output module on FMC. Okay, so this is an example. For example, it's not using all of the generic custom nodes in ITER in NDS, but developing their own nodes. So it demonstrates that it's possible to use the basic of NDS and then develop your own customized functionality. Also, NDS is used outside ITER for JET and ECS and ESS with some analog data acquisition modules, both in PXI and micro TCA form factor. And one of the examples that the most of the complex examples that we have in NDS is this NDS Systems sample. The idea is that we have in one system several devices. Okay, so we have here one analog data acquisition device, a timing board. We have archiving, we have real-time application, and some other systems, and this will require some synchronization between them. Okay, so the idea is that we have a meta device and NDS system. So a device that will be the root of the father of all these devices, and it will be managed. It will manage the synchronization between all these devices. Okay, so this is a very good example to look at it when developing a complex system. So just before finishing with the conclusions, I want to give you a quick taste of what would be to code device driver with NDS. So first of all, when we want to develop a device driver for NDS, the first thing, of course, is to check if we have already support for this device in NDS, because then we can just reuse it. But let's suppose that we don't have it. So the first thing will be to determine what are the functions that I will provide with my device, the device, not the application, not the I&C. So let's differentiate that. This device can provide these functions. So then we map these functions to NDS node structure, and we can check the user manual to see what are the existing standard nodes. And if necessary, we can extend these nodes or define our own custom nodes. Then we will create the classes that will provide the implementation, the device related implementation to these generating nodes. And then we create the node structure and the Epic database. But I won't enter very much in this Epic database because it's very straightforward. Okay. So in this example, we will have, let's say, I have a very simple device, but it's not supported into NDS yet. So it will be managed by a state machine, and it will have only small functions with health monitoring and firmware management. And for the firmware node, what is already in the standard, the functions of the standard firmware node are enough for me, but not for the health monitoring. But because, as I said before, health monitoring node has not considered the signal quality, and I want to, it's an important function for my system. So I will have the standard functionality of a health monitoring node plus the signal quality function. Okay. So how I will do it? So I create my device and this structure in which I will have the standard root node for NDS. So that will be connected to that will be the link between my device and the control system. Okay, that is how it is implemented in NDS. Then I will have standard NDS machine and classes for the implementation of the standard NDS node. So these are custom classes because they must have knowledge of the device, but it will implement the standard functionality of the NDS firmware and NDS health monitoring node. So for the state machine is quite straightforward. We in the constructor of my device, I create the root node and I create the state machine and provide the link to the functions of my device that will manage this state machine. So what my device should do when it's turned off, when it's turned on, when it's started to the acquisition, when it's stopped. So that calls are already available in the state machine, but of course the state machine doesn't know how to start and stop my device. So this is what I will provide it. So I will provide the implementation for the state machine, and I will add this state machine to the root node. So it will be already part of the NDS standard structure. So for the other nodes, in my device constructor, I will just create my implementation node, and I will give them access to the root node. Then for each of these nodes, they will create their standard NDS counterpart, so the NDS interface, and provide the links for the implementation of the functions that are in this firmware node. So this firmware node will have a standard set of PVs to access the firmware version and to change the firmware version, and I will provide how these functions are implemented in my device. Okay, but the interface for accessing that functions will be generic and will be the same for every device having this NDS firmware node. In the case that we want to have some customization, like in the health and health monitoring node, the first part is just the same or very similar, and then we just create a standard NDS PB, and we will bind that PB with the functionality in my device that will provide the signal quality, for example. So that is, instead of having the functionality bind in a hardware monitoring node, as this node doesn't know anything about signal quality, I will just create a standard NDS PB, provide the PB with the functionality to access the signal quality of my device, and link it to the standard NDS node. And with that, and thanks to the core functionality of NDS, we will have that already available in the in the control system, even if before us, this hardware monitoring node, health quality node, didn't know anything about signal quality. Okay, so that is how we provide extension to the standard NDS functionality. Yeah. So that was how we implement device integration in NDS. And just to remind that once we do that, then the rest is already done. We have the interface with EPIC already provided by the NDS, with DAN, with NDS, and with the rest of the devices that are already supported by NDS. So I will let me finish with just some conclusions. So the message here is to think twice about deviations from the hardware catalog, because most of the time may not be really necessary, or there will be some other workarounds that may work, and it will just save a lot of time. And just because you might not be familiar with that piece of hardware or software doesn't mean that it will be easier to just do your thing, because most of the times you will face with unexpected problems that if you will have followed the standard plan that we have for the system, you will be safe for that. And normally deviations comes out with additional work cost and risks that are not always well estimated. Then for what we provide, and when you stay within the catalog, we offer plenty of resources for the integration that will help the plan developers. So a lot of work that's have been already done, and it's very easy to reuse. It has not a big cost to enter into that and to learn about the tools that we have, and it will really make worth the effort of getting to know this NDS and this driver. Also, you will be spared from doing some work that is very difficult, as and then might be proved very difficult, as is these interfaces with DAN, SDN, and so on. So if you reuse what you already have available, you will be able to focus only in the specific of your system, and you will reduce the cost of your system. So yeah, basically the message is that sometimes it is better to think twice before start working on that, and maybe evaluate other options that, even if will require a little time before going forward to your development, and in the long run, it will save you a lot of work and a lot of problems. So that was all of my talk. Thank you very much for your attention, and I think that we have some time for questions if someone have them.
Thank you, Sergio. You are exactly on time. Yes, so we have time for a long discussion. I think we have in the planning 20 minutes for discussion. And I really like your on your previous slide the sketch. It's really summarize what we should avoid, and yeah, we can gain, as you stated, we can gain time and money by applying some common solution between us.
I must say that I think that I take this this drawing from one Anders' presentations, but I totally agree with that.
It's perfect. I see that in the chat we have some questions already. So by order of arrival, I have Stefan. You want to?
Yes, my question was only whether these nodes mentioned on slide 24, whether they are basically a functional breakdown like we do for the plant I&C, but in a simplified way for the device.
They practically, I mean, they hadn't been developed exactly in the keeping in mind the functional breakdown, but the FBS, but they match it pretty well.
Yes, but it's a simplified breakdown for device functions. Like it's breaking it down into health, data acquisition, and so on. Different aspects. It's the same, but with a simplified view on a device.
Yeah, exactly.
Okay, thank you. So then we have Evgeny who had a question. Don't hesitate to log your question in the chat or to raise your hand on this Teams tool, which is Reaction. Yeah, and then we can move to. Go ahead, Evgeny. Yeah.
Yeah, my question is, we've developed the NDS driver for one of our devices, and we didn't know that we shouldn't add nodes. Can we have some kind of node review to prove it or disprove, or you can give some advices? What can we do without these nodes?
Well, in fact, I don't know what is the procedure for that. I think that yeah, in principle, I think you can contact Stefan or maybe Ralph. That is the one that is in managing the development of NDS, and there could be a review on that, so to see if they can be mapped to standard nodes. The thing is that. It's not that you are not supposed to develop nodes, but there must be a reason. There must be a reason for that, and as possible, it would be better if you can adapt a little to the standard architecture. And if not, maybe it's that a problem that there is some requirement that has not been considered for NDS. So this will always be a tool for the users, and also as you as a user, if you find that. There is some function on your system and you consider that is quite normal and why it's not considered in the data acquisition node, then there can be a discussion whether, okay, it's just your case and then add your node or create your node and add your functionality, or whether it's a problem in NDS that this data acquisition node doesn't have that function, and there is a problem of ITER, and ITER will provide the solution. ITER will modify and will add that to the data acquisition node.
Yeah, okay. I just need a person whom to address.
Yeah, I think that the contact for that to see whether your functions might be included into one node or another, you can contact Ralph and me, and we can have a look on that and have some discussion.
Okay, thank you.
Okay, thank you. Next, I see. Janish, sorry if I pronounce it not correctly.
It's Yerne, it's fine.
Yerne. Okay, sorry.
So Sergio, thanks for the presentation and for all the resources you put on there, because this is going to be quite useful for me. but I have just a question. When starting with a project which will use NDS, what would be your recommended way to start? Whether there is a blank template, whether we reuse something that you show, or we start from scratch?
That depends. Okay, so let's say if you are going for a completely new device that is not integrated into already in NDS, you can go to NDS Core and NDS Epics projects, because there you have sample projects. Okay, so sample devices that are just software mocking devices, where you can see how a very simple device, can you create a very simple device with input output PVs. So that would be the simpler thing. And then from that, you can take reference of one of the devices that are already supported. If not, let's say that you have something that is quite similar to the micro TC. No, this is before. Sorry. So that is quite similar to the micro TCA device, but just the firmware will be different. Then my approach will be, once I get to know a little of NDS with the resources that are provided in the sample devices that are in NDS Core and NDS Epics, I will have a look on this, and you can use it as a reference. There is no such the closest thing to a blank project, as you mentioned, would be these simple devices that are in the NDS Core and NDS Epics projects. Okay, and there also you have in the manuals, in the user and developer manuals, you will have tutorials and, let's say, an instruction on how to create your device and how to provide the functionality and so on. So there have been a lot of work invested in this documentation. So I think it will be useful. And again, I think that the message is, if this documentation finally proves not to be useful, you can raise your concern to the maintainers of this. That is Ralph, and me as a former developer, I also interested on that. And then we can try to provide a solution, because finally these tools are made for the users, and if they are not useful for the user, then we are doing something wrong, and we will try to fix it.
Okay, thanks for the input.
Okay, thank you. Cedric has a question.
Yes, Cedric from Bertin. Hi, Sergio.
Hi, Cedric.
I would like to know where we can find the list of already supported devices, especially for codes. I think for instance, step motor controllers and so on.
Yeah, I don't think that there are these kind of devices are already supported into NDS. I think that something similar was done with the because I mean not everything is integrated into NDS, but also the idea here is that there is a lot of work already done by the Epics community. Okay, so these kind of devices like the stepper motors and some other devices are not integrated into NDS, but you can find a nice Epics IOC, an Epics driver implemented with ISIN driver, with PU ISIN driver. And maybe the better option is just to integrate that. So for that, there is the support of NDS PV access that basically is a way to interface with other Epics IOCs. So if you have already a device driver that is working with with an ASIN driver in the Epics community that is already working with your custom device or your COTS device, you could have it running in one Epics IOC, and then having this NDS PV access to interface with that, and then have it interface with Epics. Of course, this is as long as you don't have strong requirements for the data archiving and performance, because you are jumping over the system memory and so on. But as long as that is not a problem, you can use it. And if not, you can try to map what is developing in a SIM driver to this. But for the NDS, I think that I can try to ask Ralph, that is more aware of this, to see if there are more devices that are than those that I mentioned here, supported into NDS, and we will forward it to the attendees. Okay.
Okay, thank you.
So, should we take an action on that? Maybe just Stefan, because this is really a key point that we should get all the devices that are already integrated, either fully in Kodak or maybe to some extent within the EPIX community. It would be really good to have some kind of catalog. So just list of device with the tick box. Is it fully integrated in EPIX or fully integrated in Kodak? Because I think a lot of work have been done by other PBSs that we don't know in diagnostic, and a lot of things that we do could be useful for other PBSs. So it would be good to have at Kodak level a full live list of the ongoing activities.
Yes, absolutely. We had already discussed in previous workshop to collect a list of all the devices planned by I&C developers in diagnostics to be used, and then identify the status of software support in the community, either EPIX community or on ITER side, or with other developers. So this is now an action to execute. Yeah.
Okay, thank you.
Okay, very good. And Cedric has a second question, which is the ITER Git. Is it accessible to externals?
I mean, Git is completely accessible to external. If there is someone interested in accessing that, they only need to ask access, specific access to that, the same like SVN. So I think that again, I don't know, maybe Stefan or Artur may know more about that, but you can have contact your IO contact person, your technical responsible officer, or whoever, and they will provide you with access to the ITER kit.
Okay, thank you, Sergio.
Is there any other questions? Otherwise, I have some
Sergio,
myself.
I have a quick question,
Marco.
a clarification to Sergio. Sergio, if you go to the slide where you show the example where there is the firmware and the other, the first one. Yeah, no, sorry. Where you show
the code.
No, go on. There is the first sketch you do on the example.
This one.
No. Where you do the implementation. Okay, anyway, go back. Yeah, you said here that for you said maybe not here, but you remember probably. You said for the firmware implementation you are happy. I recorded this word.
Yeah.
And not for the other. I think you are partially happy because you have any way to extend the firmware implementation because you don't know when you start how to read the firmware implementation. So you have to extend both of them, the monitoring and the firmware. So I only ask you why you are happy.
No. Let's say let me explain this. Maybe it wasn't clear, but the thing is that NDS is just a structure. It's just the interface. Of course, it doesn't know about your device because I mean your device is something that you just did, or this is a new device from a micro TCA hardware manufacturer. But the functions of my device, the functions that I want for my device, are already considered in the firmware node.
So this is why you are happy then.
Yeah, I'm happy,
okay.
but I always will need to provide the link between the firmware interface and the calls to my driver, because the calls, finally the software that manages my driver is differently. But then the different thing is that for the firmware I'm happy because all the functions that I will have in my device related to firmware are considered in NDS firmware node. But for the health quality, I have one important function for my system that is not considered. But doesn't matter if they are considered or not, I will need to provide this implementation, the implementation of these functions. So NDS will give me the interface. Unless there's the NDS support for the device is already developed, you will need to implement that interface because NDS is agnostic.
No, yes, I agree. So you are happy because the firmware is anyway foreseen as a virtual function, let's say.
Yeah.
And the other has to be actually added in some way.
Yeah.
Okay.
So this is just a silly example. I mean.
Yes. No, only to understand because you said happy and I recorded this. Yes.
Okay, thank you. Liz has a question.
So when we do high-speed data acquisition with a PXI 6368 and transfer all your raw data to the server through DAN, do we need to do additional development work or we just do some configuration? We know CCS has supported PXI 33 and DAN. Yeah, the idea would be just if the 6368 is the NIDAX board, if I'm not wrong. Yeah, so this has already implemented NDS device driver, and as you said, we have the NDS done. So in principle, it will be just matter of configuration of the PVs. You will configure your done topic in the done module, and you will set your node to send the data to done. And then once the data is in the done node, you are finished.
Yeah, but here's Stefan, just one comment. Not always all device functions are supported in the device support, so you need to check also.
Yeah, again, the driver has implemented some functions. Then maybe for the use that you are using of the 6368, that this is an FPGA module, you could have some other functions. Then you can extend what is already done by adding nodes, some PVs to some other nodes, or some PVs to the existing nodes. Even for the sorry, even for the existing driver. So the existing driver has already a set of nodes, and then you may want to add one node to this driver implementation. And that is also possible.
Okay, thank you, Sergio. I have a question myself. On page 16, you were talking about life cycle management. I think this is very important. You're correct, especially if I think it was 16. Yeah, or this one. Yeah, exactly. For the component which are not in the ITER catalog. But do you have an example of the component which are inside the ITER catalog, where you did this work of life cycle management? So people who cannot find in the ITER catalog the device they want, they would need to go to your second bullet of compliance in check. Do you have example of this life cycle management and what they need to provide to be sure that everything is okay?
I'm afraid that I will need to refer you to Stefan. Maybe he can answer better this question, okay, because I did not have to manage this just yet. So maybe Stefan, can you provide some inputs on this?
I have some additional slides which show what needs to be provided as documentation and deliverables in this process. But I will compile this and make it available.
Okay. Can be linked also.
Yes.
And I have an additional, so if no one else has a question, we have 1 more minute. Page 18, I noted it was a sketch. Yeah, this sketch. The device kernel module and the device library. So these are normally the the device library which is provided by the company or by the provider of the component.
Exactly.
Do we need the source for this, or what we need is just an API?
If I'm not wrong, and maybe someone other can correct me, but as long as we are in the ITER environment, we always need to be able to combine everything from source.
Okay. Okay, so this can be also a showstopper to use some device where the company don't want to share the low level.
Yeah, in fact, that would be a request for deviation, because the policy in ITER that is that everything must be able. We must be able to compile everything from the source, and that is one of the requirements, in fact, for the maintainability of the system.
Yeah.
Because at the future we will need to.
So Stefan, this is something which should be made clear, I guess.
Yes, this requirement is necessary, because if we have only binaries, and since Kodak will have to update Red Hat Linux versions, these binaries may not work with future versions of the kernel, and then we need to be able to recompile it.
Yeah. So this should be made clear, I guess, in the requirement if we go for other devices. Okay, that's all, and I think we are almost on time. If there is any urgent questions to Sergio?
If not, I will just remind you that. Well, sorry, too fast. That here you can find my email, and for the question related to NDS and so on, you can contact me. I also recommend you to contact, or if not, I will do it in your place to Ralph Lunch. That is the one that is also managing the NDS contracts and so on.
Thank you, Sergio.